So this brings us to the concept of number of g's. Number of g's is a pretty common term. You've probably heard it before, but there are two different equations for the number of g's. One is force normal, or you might have the acceleration in the x direction divided by the acceleration due to gravity. And it just depends on whether you're talking about vertical g's or horizontal g's. So this is vertical g's, and this one is horizontal g's. And it's just measuring something in multiples of what you would normally experience if you were on the surface of the planet, which is the force of gravity, if you were simply standing here, is equal to the force normal. So right now I'm experiencing 1 g. That's 1 vertical g. My horizontal g is equal to 0, which is pretty much what it normally is. Now, this means if you're at this portion on the vomit comet, you are experiencing a force normal of 0, so you're experiencing 0 g's at this particular point. What does that mean about this point right here? This is called the pull-out of a diamond. We go from here to here. What kind of g's are we experiencing right here, James? More g's than normal. We're probably experiencing like 2 g's right here. So right here, you feel like you weigh twice what you normally do. So you go from feeling like you are weightless to feeling like you weigh twice what you normally do, to feeling like you're weightless to feeling like you feel twice what you normally do. Hence the term vomit comet. Now, I'm going to read a little bit from an article called Hazard in Aerobatics Effects of G-Forces on Pilots. They took a bunch of aerobatic pilots and they stuck them in a centrifuge. In order to understand what a centrifuge is, we're going to refer back to another movie because centrifuges are popular in movies. This particular bad movie is called Rocket Man, and this is a centrifuge. As I said, that is just to give you an idea of what a centrifuge is. So they took a bunch of aerobatic pilots and put them in a centrifuge. And they measured what happened to their bodies while they were experiencing the positive g-forces in the centrifuge. Now, I'm going to read a little bit from this article. The main effects of g accelerations are upon the blood in blood vessels. The positive g effects encountered in the pullout of a dive, which is this portion right here, will impel the fluid columns of blood toward the lower portions of the body. The output of blood from the heart will thus be reduced, and so will the blood supply to the eyes and brain, which require a steady blood supply for normal functioning. Diminished blood flow and the consequently diminished oxygen supply to the head can lead to disturbances of vision, inability to coordinate muscular activity, and unconsciousness. We have 3 symptoms of positive G effects. First one is gray out. There is a graying of vision caused by diminished flow of blood to the eyes. Although there is no associated physical impairment, this condition should serve as a warning of a significant impairment of blood flow to the head. There's actually something also called red out. Does anybody know what that is? As opposed to these, kind of the opposite of gray out. Carolyn? We have too much blood in your head. It's actually negative G's. If you were to go at the correct speed, you're going to experience 0 G's here. But if you go too quickly over this part right here, or if you're upside down here, if you go too quickly here, then you're going to actually experience a negative acceleration due to negative G's, and therefore the blood is going to go to your head, and that's called a red out. It's not really talked about in this one, but anyway. Number 2, blackout. Vision is completely lost. This condition results when the oxygen supply to the light-sensitive retinal cells is severely reduced. Contrary to other common usages of the term, consciousness is maintained. In blackout, some mental activity and muscle function remains. Thus, the occurrence of blackout warns of severely reduced blood flow to the head and of a high risk of loss of consciousness. Number 3, loss of consciousness. When the blood flow through the brain is reduced to a certain level, the pilot will lose consciousness. He or she may have jerking convulsive movements. The pilot will slump in his or her seat. Possibly the pilot will fall against the controls, causing the aircraft to enter flight configurations from which it cannot recover even if consciousness is regained. In centrifuge studies, many pilots lost and regained consciousness without realizing they had done so. Okay, I now have the average threshold for gray out and blackout and loss of consciousness for aerobatic pilots put in a centrifuge study. Who wants to hazard a guess for the average threshold for gray out? Jack. 3 Gs. We have 3 Gs on the table. What else do we hear?
20.
20 Gs. We have all the way from 3 Gs to 20 Gs. How about something else? This is kind of fun. Riku?
6.5.
6.5. We have 3, 20, 6.5. Anything else on the table? Anybody else want to come in on this one? Sit down.
I'll go 5.
5. We have 3, 6.5, 5, and a 20. How about we'll skip to a loss of consciousness. How about losing consciousness? Jack?
I'll go 6 Gs.
6 Gs, man.
I'm gonna say 6.
That's fine. We can have 2 different people say 6. It's okay. Galen?
7.
7. We have 6 and 7.
9.
9.
15.
15 Gs.
5.
I was gonna say 18.
18. Interesting. So they first lose consciousness and then gray out? Okay. So here we go. The average threshold for gray out was 4.1 Gs for an aerobatic pilot. For unconsciousness was 5.4 Gs.
That was the closest.
Absolutely. So the interesting thing about this is that it is often misrepresented in movies. For example, well, that one, for example, but here's one that's even worse. This is Armageddon.
9.5 Gs for 11 minutes. I'd start praying about it right now.
9.5 Gs for 11 minutes.
How would you know?
14,000 miles an hour.
4 Gs. How long does this last? 16. 15,000. Really heavy, man. This isn't normal. What do you mean this isn't normal? This is way worse. 8 Gs. Hang tight. I'm not getting my dad. Oh my God, die! Max 22,500.
9.5 Gs for 11 minutes, all the way up to 13 Gs in this particular movie. 13 Gs. My favorite part about this is comparing Rocket Man to Armageddon. In Rocket Man, they actually attempted to do something that might happen to somebody if they were to experience a lot of Gs. They took a fan, it looks like, and they put it in his face. Right? Something. In Armageddon, the special effect they used to show many Gs was to shake the camera. Right? That was essentially it. So let's talk for a second about what you would be like if you were experiencing 13 Gs. If you felt like you weighed 13 times what you normally weigh. Class, could you stand?
No.
Could you sit?
No.
Could you talk?
No.
No, you wouldn't be able to lift your jaw. You would be a puddle on the floor. Right? If you weighed 13 times what you normally weigh, you'd be like, but you wouldn't be able to move at all. And yet, in this high-dollar movie, they shook the camera to illustrate.